Now let's combine the concept of segmentation with paging. It is slightly difficult, but then if you can follow it, it is very simple. It will be just like paging only with just one extra step. If you understood everything about the multi-level paging, all the questions in this memory management will be very easy. Only that you should understand that multi-level paging very well. So this is just an extension to that. I mean a kind of multi-level paging. I'll just show you what it is. First of all, the process is initially divided into something called as segments. Okay, so let us assume that a process is containing segments like this. These are all the segments. Okay, and next they are all the segments, and they need not be of same size. Even though the diagram looks like they are all of same size, they need not be of same size. And next thing is, I am going to divide these segments into equal sized pages. Now these segments will be divided into pages. Okay, and the same concept, main memory will be divided into, right? So let us say this is main memory, and now main memory will be divided into something called as frames, right? And in such a way that these pages will be equal to frames. So now these segments have nothing to do with the loading the main memory with the pages. So segments are closer to the user point of view, and paging is closer to the implementation point of view. So that is the benefit of this. So segmentation with paging is actually beneficial in two ways. One is user can still look at the program as a collection of segments, but the operating system will look at it as just like pages and frames, right? And see, the first most popular method is paging, simple paging, or virtual memory with paging. And the next popular method is segmentation with paging, and pure segmentation is rarely used. Okay, so anyway, the final point is, whenever CPU generates the address, the logical address, how can we know that? How to convert it into physical address? Which means if CPU is asking for a word, then how can you get into the main memory and then get that word? That is the main question, right? So in order to answer that, again there is memory management unit. The entire purpose of memory management unit is to convert logical address to physical address. Whatever address is generated by CPU, it has to convert it into physical address so that we can get into the main memory and get it, right? Now to implement this, what happened is, what we do is, first of all, for every segment we are having various pages, right? So for every segment we'll have one page table. So this is page table 1, this belongs to the segment 1, or this will talk about what are all the pages in this segment S1. Let us say this is segment S2, this is segment S3, and this is segment S4, right? So now page table 1 will talk about what are all the pages present in S1 and where they are. Either they are in the main memory. If they are in main memory, what is the frame they are present in, or if they are in the not in the main memory, it will say it is not present and you have to load it, some kind of it. So depending on virtual memory is implemented or not. Anyway, every segment is associated with one page table. So remember this, earlier what happened, the entire process used to have one single page table, but here every segment will have a page table, right? And similarly there will be one more page table for the segment 2, and one more page table for the segment 3, and one more page table for segment 4, right? Now these page tables will contain entries for the pages in the segments like this. These page tables will contain the entries for the pages in the segments. Got it? So if there are 10 pages here, then how many entries will be present in this page table? 10. If there are 20 pages here, how many entries will be present here? 20. Got it? So each entry will contain something about the page present there, right? So what should be present initially? So every page table should contain the frame number or the frame base in which this particular page is loaded. For example, let us say this frame number is F1, F2, F3, F4, F5, F6, F7, F8, like this. And let us say this particular page number is let's say it is starting with 0. There is 0 also. This page number is 0, 1, 2, 3. In case if the page number 0 of S1 is loaded in, let us say, frame number 7 of the main memory, then here in the page table, the corresponding entry of page number 0, it will say that page number 0 is loaded in frame number 7. That is what it contains. Therefore, what should every page table contain? Every page table is supposed to contain the frame number in which that particular page is present in. Got it? And now one more thing is, since we are using the paging, even these page tables should also be present in the pages. So if you are going with one level of paging, that is what we do in the segmentation with paging, we have only one level of paging, then what we can even extend it, but most of the implementations they follow only one level of paging. Therefore, what we carefully design is, we design this paging scheme in such a way that one page table of every segment, or the page table of every segment is going to fit in one particular page. So all the page tables, they should fit in one page each. Therefore, if you have 4 page tables, how many pages you should use? We should use 4 pages, or in fact I know we are talking about the frames. We should use 4 frames, and these 4 page tables have to be loaded in 4 frames. And now we should even keep track of which frames contain these page tables. Earlier, when we had only one page table, CPU used to have a register which contains the base of the page table, isn't it? But now we have 4 page tables. Now CPU has to maintain the list of all the frame numbers in which these page tables are loaded. Otherwise, the mapping forward is not possible, isn't it? That is why, in order to keep track of that, we have one more table that is called as segment table. For the entire process, we have only one segment table. This is called as a segment table, right? Now what will the segment table contain? The segment table will contain pointers to the page tables, which means each if there are 4 page tables, then it will contain, this is the first page table, this is the second page table, this is the third page table, this is the fourth page table. See, even though I am talking about directly pointing to the page table, actually what this means is, page table, this PT1 is in one of the frame in the main memory, and now we are pointing to the frame. Therefore, even the segment table entries should also be containing the frame numbers in which that particular page table is present, and page tables will contain the frame numbers in which that particular page is present. Are you following it? See, it might look difficult, but once you practice it, it's going to be very, very easy. Okay? And now, even this segment table should also be present in a frame, isn't it? Yes, it will be present in a frame. And what happens is, CPU will contain, whenever it is trying to run this process, CPU in its one of the registers, it will contain what is the base of segment table. Base of the segment table. Therefore, this particular entry will point to this one, right? And all the entries will point to this, and these will point to the pages, like where the pages are present. So if you want to put together everything and see what is really happening, let's see this. Now CPU will generate something called as logical address. Logical address can be viewed like this. One is, logical address will contain what is the segment number, right? And then what is the page number, and then finally what is the page offset. This is what logical address will contain. Now using the segment table base, we can get into the segment table. Now using the segment number that we want to access, then we get into the corresponding segment. Let us say I want to access the segment number 1. Then to the base I'll add that, and I'll get into the segment number 1. Let us say this is segment 0. We shall always start with zeros only, it will be better. Segment 1, segment 2, segment 3, and page table 0, page table 1, page table 2, page table 3, right? And let us say the segment number is segment number 2. Then what happens is, this is segment number 0, this is segment number 1, segment number 2. To the base, when I add this number, I get into the corresponding entry. And this entry will contain the base of the frame, or the frame number in which the corresponding page table of the segment 2 is loaded, which means this entry will point to the starting of a page table, right? Let us say in that page table, again we want page number 3. Then what we do is, we go to this base of the page table, and then we add 3, then we go into the corresponding entry, right? Page number 0, page number 1, page number 2, page number 3. Let us say this is the entry, right? And now this entry will contain the frame number base in which that particular page is loaded, right? Let us say that particular page is loaded somewhere here, okay? Now we go into this, and then finally the page offset will say, let us say the page offset is saying 10, which means I want the 10th word in that page. So we can go into that and we can get that word. That is how it operates. Understood this? So what is it? The entire process is divided into various segments, and for every segment we are again dividing into pages, and for every segment there is a page table. It is contrary to the other one. In pure paging, for the entire process we had only one page table, but here for every segment we have to maintain various page tables. What will these page tables contain? The frame number in which that particular page is present. Therefore, what will be the size of page table entry? That depends on what is the frame number size, and that you know that these questions we have already done in paging, right? And then all these page tables are going to point to some of the frames, right? And these page tables also have to be kept track so that we can do the mapping. For that reason we use one more table called as segmentation table. For the entire process there will be only one segment table, right? And this segment table or these page tables, everything should be in the main memory, and all of them should fit in one frame. I mean, not all of them, each one taken has to go into one frame, which means segmentation table should go into one frame, and all these page tables should go into one frame each, right? And now we should have what is that frame number in which all these are present. Now we should at least have what is the frame number in which the outermost segment table is present. For that, CPU will be loaded with this segment table base. Who will load it? That context switching. During that context switching, the scheduler, whenever it is doing the context switching, right, it is going to load it with this. Got it? Load the CPU register with this particular the base of the segment table. Now the base of the segment table will point to the frame in which the segment table is present. Now using that, you can use this logical address, and we can convert it that way. How? Now we go into the segment table, and using this segment number we can go into the page table. Now after going to the page table, using the page number we can go into that particular entry. Now after fetching that, we can get into the frame in which that particular entry is present, right? That particular page is present, and after getting into that frame we can take the page offset, and then we can get into that word. Got it? That is how logical address is converted to physical address. So if you didn't understand this, I'll just tell you how it is converted. See this. Just to make it clear how the logical address is converted to physical address, observe this. Now CPU should at least know what is the base of the segment table, and that will be loaded when you are loading the context of the process. For every process, when you are trying to do the context switching, or when you are trying to start, when you try to start running the context switching, start a process, then along with the other registers, one of the main important register is either the page table base or the segment table base, depending on whether you are using paging or segmentation, right? That is going to be loaded in that register. Now CPU knows where the segment table base is present, which means what is the address in which that particular frame is present, right? And now to this segment table base, if we add this segment number, it is going to give you a new number, right? So what is it? This is nothing but the entry in the segment table in which that particular in the segment table entry in which that particular page table is pointed to. So this number is nothing but the page table base. This number, whatever you get, is nothing but the page table base of the particular segment. Are you following this? Which particular segment? That particular segment depends on what is it you are asking. So here, if you are asking for segment number 2, this will contain the page table base of the segment number 2, right? And now this number, when it is added with the page number, right? When you add this with the page number, then you are going to see, actually this one is going to the page table base, right? Which means using this number you are going to enter into the page table, right? And now when I add this page number, I can get into the page table to the particular entry which points to this particular page in the memory, right? So which means this one will give you the number whatever we get. This one is going to give you the frame number or the frame base. The frame base of the frame, which contains the required page, right? Which contains the required page. Got it? And now finally we have got the frame base, and to that frame base, when we add this page offset, finally what we get is address of the word, which is nothing but the physical address in which our required word is present. From there you can read the word into the data bus. Now this when physical address, when this is given to the main memory, it will take it, right? Therefore this entire procedure is followed in order to convert logical address into physical address. So what are the various tables involved in this? One table is segment table, and other table is page table. So in segmented paging, memory management unit contains of two tables. One is segment table, other is page table. Using these two tables we convert the logical address to physical address. Got it? Okay.